हेलो स्टूडेंट्स। आई होप आप सब अच्छे होंगे और अपनी स्टडीज को भी अच्छे से कर रहे होंगे। तो आज का जो हमारा टॉपिक होने वाला वो प्रोबेबिलिटी थ्योरी होने वाला है। और सबसे पहले हम उस प्रोबेबिलिटी थ्योरी में रिजल्ट्स देखेंगे। ओके, प्रूफ हम इतनी डिटेल में नहीं जाएंगे। और फिर इफ टाइम परमिट्स तो हम उससे रिलेटेड, उस थ्योरी से रिलेटेड कुछ क्वेश्चंस, प्रैक्टिस क्वेश्चंस करेंगे। ओके, सो प्रोबेबिलिटी थ्योरी, आज का जो सेशन रहेगा वो मेनली रिजल्ट बेस्ड प्रोबेबिलिटी थ्योरी पर रहेगा। आइए देखते हैं कि आज के इस टॉपिक में हम क्या क्या कवर करने वाले हैं। सैंपल स्पेस एंड इवेंट्स, टाइप्स ऑफ इवेंट्स, प्रोबेबिलिटी ऑफ एन इवेंट्स, इंपॉर्टेंट रिजल्ट्स, एडिशन, थ्योरम ऑफ प्रोबेबिलिटी, कंडीशनल प्रोबेबिलिटी, थ्योरम ऑफ टोटल प्रोबेबिलिटी, probability distribution of a random variable, Bernoulli trials and binomial distribution. There is a small disclaimer. The images used in our slide deck are just for educational purposes only. We respect the intellectual property rights of the original creator and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. Thank you. Now, sample space and event. So, sample space is a set of all possible outcomes of a random experiment, and it is generally denoted by S. Example: tossing a coin, rolling a die, drawing a card from a pack of playing cards, etc. An event is a subset of sample space as: if a die is rolled, then your sample space will be 1, 2, 3, 4, 5, 6. And getting an odd number, in this case your event A will be 1, 3, 5. So as you can see, is a subset of S. Types of events: equally likely events. The given events are said to be equally likely if none of them is expected to occur in preference to the other. Okay. Mutually exclusive disjoint events. A set of events is said to be mutually exclusive if occurrence of one of them prevents or denies the occurrence of any of the remaining events. If a event of if a set of events E1, E2 are mutually exclusive, this means the intersection of the events must be phi. Exhaustive events. A set of events is said to be exhaustive if at least one of the events compulsorily occurs. If a set of events E1 to En are said to be exhaustive events, then E1 union E2 till En, the union must equals to your sample space. There is a note: if the set of events E1 to En are mutually exclusive and exhaustive, then they must be, uh, if you pick any two different event, the intersection must be phi, and the union of all event must be equals to the sample space. Types of events: complementary events. in a random experiment, if you have your S as your sample space and E as your event, obviously E be a subset of S, then E complement will be like S minus E. So all the outcomes in sample space but not in E. So this will be your complement of E. Probability of an events. Probability of an event. If the sample space S has n points and an event A has m points, then the probability of that event A is represented by PA, and this will be m divided by n. In this case, your probability must be lying in this interval or in this range. 0 greater than or equal to your probability, and this probability must be less than or equal to 1. Also, the probability of your sample space must be 1. Probability of empty event, impossible event must be 0. Probability of odds in favor of A is defined by probability of A divided by probability of A complement. In other words, m divided by n minus m. Probability of odds in against A. This will be probability of A complement divided by probability of A. This gives you n minus m divided by m. Now let's see some important results. Important results. If n letters corresponding to n envelopes are placed in the envelopes at random, then probability that all the letters are in a right envelope will be 1 by n factorial. Probability that at least one letter not in right envelope will be 1 minus 1 by n factorial. Probability that no letter is in right envelope is given by this dearrangement formula. Probability that exactly r letters are in right envelope is given by 1 by r factorial, product with 1 by 2 factorial minus 1 by 3 factorial till minus 1 raised to the power n minus r, product with 1 by n minus r factorial. Addition theorem of probability. Now let's see the addition theorem of probability. If A and B are two events associated with a random experiment, then the probability of union of the events must be probability of A plus probability of B minus probability of A intersection B. If you have three events associated with a random experiment, then the probability of union of all the three events will be probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. For any two events A and B, the probability of A intersection B always be less than equal to probability of A, and this will be less than equal to probability of A union B. This will be less than equal to probability of A plus B. Now Boole's inequality. Probability of A intersection B is greater than equal to probability of A plus probability of B minus 1. Probability of A intersection B intersection C is greater than equal to probability of A plus probability of B plus probability of C minus 2. Now some more results related to addition theorem of probability. There is a note. Probability of A complement intersection B complement is equals to 1 minus probability of A union B. Probability of A complement union B complement is equals to 1 minus probability of A intersection B. Probability of A is equals to probability of A intersection B plus probability of A intersection B complement. Probability of B is equals to probability of B intersection A plus probability of B intersection A complement. Probability of exactly one of event E1, E2 occurs will be probability of E1 intersection E2 plus probability of E1 complement intersection E2. This can be rewritten as probability of E1 minus probability of E1 intersection E2 plus probability of E2 minus probability of E1 intersection E2. Rearranging the terms, you will have probability of E1 plus probability of E2 minus 2 times probability of E1 intersection E2. Now, probability of neither E1 nor E2 occurs. This will be probability of E1 complement intersection with E2 complement, which will be 1 minus probability of E1 union E2. Now, conditional probability. If A and B are two events associated with a sample space of a random experiment, then conditional probability of the event A given that B has occurred is denoted by probability of A by B and defined like this. Probability of A intersection B divided by probability of B. Now properties related to conditional probability. Let A and B be two events of a sample space S of an experiment, then probability of S by A is equals to probability of A by A is equals to 1. Probability of A complement by B, this is your just nothing but conditional probability. Probability of A complement when B has occurred will be 1 minus probability of uh, A as B occurred. Now multiplication theorem of probability. Multiplication theorem of probability, let's see. If A and B are two events associated with a random experiment, then probability of A intersection B can be rewritten as in terms of conditional probability. Probability of A intersection B is equals to probability of A product with probability of conditional probability of B as A has occurred, which is further rewritten as probability of B product with conditional probability of A as B occurred, where obviously you are taking probability of A is non-zero here and probability of B non-zero in here. Now independent events, let's see the definition. Two events are said to be independent if the occurrence of one does not depend upon the other. If you have E1 to En independent events, then the probability of intersection of all events must be equal to the probability of the product of individual events. If E and F are independent events, then the pairs E F complement, E complement F, E complement F complement are also independent. Theorem of total probability. If an event A has can occur with one of n mutually exclusive and exhaustive events B1, B2 till Bn, and the probabilities, the conditional probability as of A as B1 occurred, conditional probability of A as B2 occurred till conditional probability of A as Bn has occurred are known, then you will have probability of A is equals to summation of probability of Bi product with this conditional probability of A as Bi has occurred. Now Bayes theorem, if you have a sample space S and the union of n non-empty disjoint subsets, obviously we are talking about mutually exclusive and exhaustive events, that is the union of all events must be equals to S and they must be also mutually disjoint, or pick any two different events, the intersection must be phi. So for any event B, so take any event such that if this is followed, B is equals to A1 intersection B union A2 intersection B union till AN intersection B. Okay, as you know that A1 union A2 union AN, the intersection with B will gives you this form. So you will have this conditional probability of AI by as has B occurred will be the probability of AI intersection B divided by probability of B, which can be rewritten as further probability of A product with probability of this conditional probability of B where AI has occurred divided by probability of a summation of probability of AI product with this conditional probability of B as AI has occurred. Now, probability distribution of a random variable. A random variable is a real valued function whose domain is sample space. Random variable is usually denoted by capital letters x, y, z, and so on. If a random variable x takes values x1 till xn with respective probabilities p1, p2 till pn, then this form, as you can see here, is known as probability distribution of x, where for x1 it is related to p1, x2 related to p2 till xn related to pn. Now some more points on probability distribution of a random variable. The probability distribution of a random variable x is defined only when the various values of random variable, example x1, x2 till xn, together with respective values p1, p2 till pn, must satisfy what that first of all the sum of all pi's must be 1. Each one of the pi must be strictly greater than 0. Now mean. If a random variable x assumes values x1, x2 till xn with respective probabilities p1, p2 till pn, then the mean x bar of x is defined as summation of pi product with xi, or in expanded form p1 x1 plus p2 x2 till pi xi. The mean of a random variable x is known as its mathematical expectation and it is denoted by ex. Variance. If a random variable x assumes values x1 till xn with the respective probabilities p1 to pn, then the variance of x is given by where x, and it is evaluated by using this formula, summation of pi product with xi square minus summation of pi xi then whole square. Now Bernoulli trials and binomial distribution. Bernoulli trials Trials of a random experiment are called Bernoulli trials if it satisfies the following conditions. First of all, there must be finite number of trials. Trial should be independent. Each trial has exactly two outcomes, either success or failure. The probability of success or failure remains the same in each trial. Now, binomial distribution. The probability of our successes in an independent Bernoulli trials is denoted by probability of x is equals to r and is given by NCR p raised to the power r q raised to the power n minus r, where your p is the probability of success and q is the probability of failure, and there is a relation between p and q which is p plus q is equals to 1. Now mean, in this case you will have mean and p, variance as npq. Mean is always greater than variance. So this is it for this theory session. Just wait for a moment. We will be back with some more practice problems. वेलकम बैक. सो जैसा कि अभी हमने थ्योरी को कवर किया, तो अब चलिए कुछ प्रैक्टिस क्वेश्चंस करते हैं थ्योरी से रिलेटेड. सो प्रोबेबिलिटी प्रैक्टिस क्वेश्चंस पार्ट 1. So let's see index. Practice questions 1 to 6 we will be covering if time permits. There is a small disclaimer. The images used in a slide deck are just for educational purposes only. We respect the intellectual property rights of the original creator and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. Thank you. Now, the question: if three distinct numbers are chosen randomly from the first 100 natural numbers, then the probability that all the three of them are divisible by 2 and 3 is 4 by 55, 4 by 35, 4 by 33, or 4 by 1155? It's a simple question. So you will have 30 seconds to try this problem, and then we will move towards its solution as well as the correct option. So your time starts now. As your time's up, so let's see what will be the correct option. So as a question says, the three distinct numbers are chosen randomly from the first 100 natural numbers, then the probability that all the three of them are divisible by 2 as well as 3. So the correct option will be option D. The probability will be 4 by 1155. So let's see the solution. So first, formula and key points used. If a number is divided by both 2 and 3, it means that the number is also divisible by 6. Selection of R distinct things from N distinct things is NCR. Now, probability of any event A is just nothing but the favorable outcomes of A divided by total number of outcomes. Now, solution. Here in sample space, we have 100 C3 as total number of outcomes. Let E be an element where E represent all three of them are divisible by both 2 and 3, meaning divisible by 6, meaning this set includes 6, 12, 18 till 96. Then out of 16, we have to select 13. So these are all 16. So number of favorable cases or outcomes will be 16C3. Now the required probability will be 16C3 divided by 100C3. This after reduction you will have 4 divided by 1155. So the correct option will be option D. Now this question, this says if the letter of the words mathematics are arranged arbitrarily, the probability that C comes before E and E before H and H before I and I before S will be what? 1 by 75, 1 by 24, 1 by 120 or 1 by 720. You will have 30 seconds to try this question. After 30 seconds, we will move towards its correct option and explanation. So your time starts now. As time's up, let's see the correct option. So as question says, if you have this word and from this word you have letters, if you have to arrange these letters arbitrarily, and then you have to find the probability that C comes before E, E comes before H, H comes before I comes before S. The correct option will be C. The probability will be 1 by 120. Let's see how. First of all, formula and key point used. The number of permutation of n things taken all at a time when p of them are similar and one of uh, one kind, q of them are similar and another of another type, r of them are similar and of third type, and remaining n minus p plus q plus r all different. The number of permutation is given by n factorial divided by p factorial q factorial r factorial. Probability of events uh, by definition is evaluated as number of favorable cases or total outcomes, number of favorable outcomes divided by number of total outcomes. Now solution. Total number of arrangement is 11 factorial divided by 2 factorial 2 factorial 2 factorial, which is just 11 factorial by 8 factorial. Number of arrangement in which C, E, H, I, S appear in that order as C, E, H, I, S. So this will be 11 C5 product with 6 factorial divided by 2 factorial 2 factorial 2 factorial, and this can be rewritten as 11 factorial divided by 8 product with 5 factorial, where your 11C5 represent the selection of 5 positions out of 11 position to place C, E, H, I, S in that order. As required probability will be that this favorable, okay, so favorable outcomes divided by total outcomes. So this after reduction you will have 1 by 120. So that's why option C is the correct option. Now this question, if A and B are two events, then the probability that exactly one of them occurs is given by probability of A plus probability of B minus 2 times probability of A intersection B. Probability of A intersection B complement minus probability of A complement intersection B. Probability of A union B plus probability of A intersection B. And the D option, probability of A complement plus probability of B complement plus 2 times probability of A complement intersection B complement. You will have 30 seconds to try this question. After 30 seconds, we will jump to its correct option and its explanation. So your time starts now. As your time's up, let's see the correct option and its explanation. So as question says, if you have two events A and B, then the probability that exactly one of them occurs is given by the option A. Probability of A plus probability of B minus 2 times probability of A intersection B. Let's see how. So formula and key points. P either only X or only Y occurs. So this can be rewritten as probability of X intersection Y complement union Y intersection as X complement. So this gives you probability of X union Y. This will be probability of X plus probability of Y. So this is only when the intersection of X and Y is phi, or X and Y events are disjoint events mutually. Also, you have this thing that probability of X can be rewritten as probability of X intersection A Y complement plus probability of X intersection Y. Now solution. So probability of exactly one of the events occur, meaning probability of A intersection B complement union probability of B intersection A complement. And from here you can easily rewrite it as probability of A intersection B complement plus probability of intersection A complement using this point. So this gives you probability of A plus probability of B minus 2 times probability of A intersection B. And this was given in the option A. Okay. Now this question, and this will be the last question for this session. The probability that at least one of the event A, B occur is 3 by 5. If A and B occur simultaneously with probability 1 by 5, then probability of A complement plus probability of B complement is equals to 2 by 5, 4 by 5, 6 by 5 or 7 by 5. So you will have 30 seconds to try this problem. After 30 seconds, we will jump to its solution and correct option. So your time starts now. तो जैसा कि आप सभी का समय ओवर हो चुका है, तो चलिए अब देखते हैं इसके सॉल्यूशन को, इसके करेक्ट ऑप्शन को। तो जैसा कि क्वेश्चन में दिया गया है कि प्रोबेबिलिटी दैट एटलीस्ट वन ऑफ द इवेंट्स ए एंड बी अकर इज 3 by 5 और आपसे और प्लस और इन्फॉर्मेशन क्या दी गई है कि ए और बी इवेंट्स के होने की, दोनों के एक साथ होने की जो प्रोबेबिलिटी है वो भी कितनी दी गई है, 1/5 दी गई है। पहले आपको 3/5 दी गई है। ओके। तो आपसे पूछा गया है कि प्रोबेबिलिटी ऑफ ए कॉम्प्लीमेंट प्लस प्रोबेबिलिटी ऑफ बी कॉम्प्लीमेंट क्या होगा। तो इसका करेक्ट आंसर रहेगा ऑप्शन सी, 6/5। आइए जानते हैं किस तरीके से। सो सबसे पहले जानते हैं फॉर्मूला और की पॉइंट्स को जो कि यूज होंगे इस सॉल्यूशन में। सो प्रोबेबिलिटी ऑफ ए यूनियन बी बराबर होता है प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ बी माइनस प्रोबेबिलिटी ऑफ इंटरसेक्शन बी के। दूसरे जो पॉइंट आपको पता होना चाहिए वो प्रोबेबिलिटी ऑफ ए इक्वल होता है 1 माइनस प्रोबेबिलिटी ऑफ ए कॉम्प्लीमेंट के। और आपको अगर ये दो पॉइंट्स पता है तो आप सॉल्यूशन काफी आसानी से कर लेंगे। आइए जानते हैं। सो प्रोबेबिलिटी ऑफ ए यूनियन बी हमें क्या दिया होता है, 3/5 एज एटलीस्ट वन ऑफ द इवेंट्स अकर, मीनिंग ए यूनियन बी। और दोनों के एक साथ होने की जो दे रखी थी साइमल्टेनियसली, विच मीन्स प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी, वो दे रखा है 1/5। तो एडिशन थ्योरम से हमारे पास आएगा, अगर आप फर्स्ट पॉइंट का यूज करेंगे तो आपको मिलेगा 3/5 इज इक्वल टू प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ बी माइनस 1/5। और यहाँ से आप क्या लिख सकते हैं, रीअरेंज करेंगे कांस्टेंट टर्म्स को, लेफ्ट हैंड साइड पे मिलेगा 4/5 और राइट हैंड साइड को आप रिड्यूस कर सकते हैं सेकंड पॉइंट से। ये हो जाएगा 1 माइनस प्रोबेबिलिटी ऑफ ए कॉम्प्लीमेंट और ये चेंज हो जाएगा 1 माइनस प्रोबेबिलिटी ऑफ बी कॉम्प्लीमेंट के। फिर से आप रीअरेंज करेंगे तो आपको क्या मिलेगा, प्रोबेबिलिटी ऑफ ए कॉम्प्लीमेंट प्लस प्रोबेबिलिटी ऑफ बी कॉम्प्लीमेंट इज इक्वल्स टू 2 माइनस 4/5 विच इज इक्वल्स टू 6/5। तो इसीलिए हमारा ऑप्शन सी 6/5 एकदम करेक्ट ऑप्शन था। तो जैसा कि हमने बताया कि आज के इस सेशन का ये आखिरी प्रश्न था। सो तो हम अपने इस लेक्चर को यहीं पर एंड करना चाहेंगे। थैंक यू फॉर ज्वाइनिंग दिस सेशन।